Now we are live, Pimmy. You can go ahead. Thank you.
Good afternoon, everyone. Welcome to the MEC 5G Hackathon, which has been organized jointly by the Indian Institute of Technology, Delhi and TSTSI. Developers and their teams were invited to develop applications and run them on the 5G MEC Testbed, which is part of the indigenous 5G Testbed project funded by the Department of Telecommunication, Government of India. Of all the teams that registered their applications to this MEC 5G challenge, 2 teams have been shortlisted. They will be showcasing their demos, and the demos will be awarded prizes for being the most innovative and the most impactful application. The basis for these awards includes conceptualization, the overall implementation, architecture, and features, their implementation on the MEC platform, the parameters in terms of scalability and performance, and the presentation. We have with us today Professor Huzur Saran, the principal investigator of the indigenous 5G testbed project, Professor Brijesh Lal, the co-PI of the project, and Professor Arzad Alam Kherani, who is leading the MEC testbed team at IIT Delhi. He is an adjunct faculty at Bharti School. Also, as members of the jury, along with Professor Huzur Saran, we have Mr. Manish Gange, Head R&D Airtel. He has a deep understanding of technology, its applications, market fitment, and impact on business. We also have Mr. Prabir Datta, Distinguished Engineer, Hughes System. He has extensively worked in embedded and wireless access areas, both in the network and the user terminal. I now call upon Professor Huzur Saran for the opening address. Over to you, Professor Saran.
Thank you, Pimi. It's a pleasure to briefly talk about the efforts being done. So, of course, I am sure many of you are aware that the Government of India, the Department of Telecommunication in particular, has funded a large 5G testbed project almost 3 years ago, and we are almost at the end of that project now. And in that testbed project, which was done jointly by many IITs, led by Professor Bhaskar Ramamurthy from IIT Madras, who is also the director of IIT Madras, a lot of different 5G technologies have been built indigenously and demonstrated. Even recently, the Parliament Standing Committee had visited IIT Madras to look at some of the equipment that have been built, millimeter wave radios, base stations. Also, of course, IIT Delhi has been very active in edge computing, which is what we are talking about today, Internet of Things, applications, security. In the morning today, a seminar was held by Professor Harshan, where he demoed a lot of security technologies for 5G. So there is overall a lot of activity in 5G, and through the interest shown by the Honorable Minister and the government in funding this and carrying it forward. We are also looking at now beyond 5G up to 6G. So Brijesh is leading an effort at IIT Delhi along with others, including myself, on looking at beyond 5G, whether we call it 5.5 or 6. I think 6 is a little premature to say, but definitely taking these things beyond the current state of play to even more advanced topics. So there is a great commitment from all the academic institutions and R&D institutions, and I'm happy to welcome Mr. Manish from Airtel and Mr. Prabir from Hughes System, who are both, Airtel being one of the premier operators in this country, would be a potential user for such kind of technology. So their inputs are very relevant. And similarly, Hughes has been one of the pioneers in the telecom space in India from early days, and so their involvement in this shows the seriousness of the entire effort and commitment from both all parts of the Indian ecosystem to promoting this. As regards mobile edge computing so the point is, in the end, what we care about is, if as a user, all you care about is, okay, somebody says 5G, says, oh, what's the big deal? I got iPhone 13 is launched now, and iPhone 12 was launched last year, and they support 5G. Great. If I buy it, I pay 1 lakh rupees, 70,000 rupees for it. What does it get me? See, flip it around from the user's perspective. What does it mean for the user? Right? And that is where applications come in. Unless we, yes, 5G brings in a lot of interesting capabilities. But unless we are able to expose those capabilities and build meaningful applications which add utility to the user and make it really something that was not possible with 4G. Up to then, just talking, saying 5G, 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 you have a 5G phone is of no relevance to the user. Why should he pay even a rupee more for it? Right? And so in that context, this hackathon and the effort around this is very relevant. And I thank all the participants who submitted their projects. And I look forward to listening from the shortlisted participants on what they have achieved. And as you know, one of the key elements of this 5G, and in fact, even 4G, is the idea of having some computing close to the point of the user so that you can have very low round trip times. And so you can very quickly react, especially for AR, VR, or other kinds of applications. So Professor Arzad has been leading the effort within the 5G testbed that we have at IIT Delhi on mobile edge computing, and he has been done a very lot of contributions has made to make it possible for application developers to actually use this and demonstrate something. So we look forward to hearing more about what kind of applications become possible once you enable MEC and all the other 5G features. And I will stop there and look forward to listening from all of you. And in the end, I'm sure the other jury members will also give their views, but let's wait for your presentations first, and then in the end, we'll request them to give their thoughts also. Thank you.
Thank you, Professor. I now request Professor Brijesh Lal to give us some more insights to the 5G testbed. Over to you, Professor. Sir, you're not audible.
Okay, thank you, Vimmi. Sorry for that. I think I muted myself. Thank you, Manish. Thank you, Pravir, for joining us. It's a privilege to have you on the jury. Thank you, Husuran sir, for making time, and Arzad for making this MEC thing happen, leading it from the front. So I will say a few words about the MEC with respect to the current project and how do we move forward, and a bit about the genesis for this particular hackathon, and then I'll hand it over to Arzad to give you details of the MEC work that we've done here. So the whole idea of this was for the last 7 or 8 years, there had been a slow but steady move towards convergence of compute and communication. Now, MEC represents the first element of the network which combines the two and cannot do without either of the two capabilities. You will see more and more points of the network having this capability with varying degrees of factorization between the the compute and the comm, but this is something that's going to become more and more common. So MEC is the first network element in that sense, which shows us the future of communication, or the future of compute, depending on how you want to view it. So this idea for contributing to the MEC came to us 4 years ago when this particular project was visualized, and this project was visualized. IIT Delhi thought of contributing to 5 areas, one of which was the mobile or multi-access edge computing, MEC architecture. Over the last 3.5 years, we've built a team up. We've got systems in place to have now a demonstrable setup and a test bed for other people to come and experiment on. We've got a couple of demos in the area of haptics working already, which Arzad will talk about in detail. but there are a couple of other low latency applications which are envisaged and are being worked on as we speak. One of them is about immersive sports viewing. So what we want is using an Oculus, can we give the user as close to the sports field as possible experience by multiple drones capturing the action from different viewpoints. And there's another one on precision agriculture, where we want to have low latency deployments of drone-based solutions, which are actually augmented by on the land or in the farms kind of sensors which sense soil conditions, weather conditions, and such other information. So this is the idea of how we want to build applications within the group. But as Professor Saran pointed out, the number of applications, the number of verticals, and the number of use cases is not restricted to this very narrow set that I spoke about. And for this reason, one of the goals of this effort is to make this test bed available to as many people as possible, so that more and more of them can come and contribute to the ecosystem and come up with India specific and India made solutions for India and even for markets outside the country. So with this goal in mind, we intend to continue to contribute to this particular space as part of a newer project that Professor Saran alluded to. So now what we're trying to do is, given that we have a test bed in place, we will keep on working on applications and we will keep on enabling applications by other players, but we'll also try and build IP on top of what we've already made. So with this kind of a vision in mind, we are lucky to have Manish and Praveer here, because the thoughts that they share with us today will help us correct a direction if it is needed, and also they will get an idea of what we're doing, and there are possibilities of future joint works. So thank you everyone again. Back to you, Pimmi.
Thank you so much, Professor. Next, I request Professor Arzad, who is Associate Professor at Department of Electrical Engineering and Computer Science, IIT Bhilai, and Adjunct Faculty at Bharti School, IIT Delhi, and leading the MEC initiative at IIT Delhi under this project, to acquaint us with the multi-access edge computing technology and the 5G MEC testbed. Over to you, Professor.
So good afternoon all. Thank you, Professor, and thank you, Professor Lal. And also thanks to IIT Delhi for including IIT Bhilai in this activity, in this nationwide testbed activity. So what I'll do is, I hope my screen is visible to all now.
Yes, sir.
Okay. Thank you. So first of all, I'll start. So the objective of my discussion with you is basically tell you a background on what are the design challenges that we faced when we started this activity, and what was the workaround kind of roughly at a high level, and then hand it over to the team which has developed. All of this activity would not have been possible without active participation from many contributors. So Gaurav, Ashish, and Shashwat, and Munib, and Pimi also. So there are many. I'm sure I have missed a few. So apologies to that, and thanks to Vinti ma'am and Gautam also for helping us throughout. In terms of overview, as Professor Saran also said and already said, and as Professor Lal also conveyed, edge, the objective behind edge computing. So edge computing is not new. The concept is not new. The realization that this will help the operators is also not new. There has been activities around this for last 7-8 years already, almost close to a decade now. And this is still an evolving technology in terms of getting more and more applications that integrate with the service providers network. So edge computing in other contexts where we are not talking about cellular are already there, right? So there are many proprietary solutions already available. When we start talking about cellular, then we need to make sure that there's interoperability and the vendor independence and all those kind of requirements start coming in when we talk about cellular systems, right? Any modification to cellular systems, which is supposed to be open to others. So the motivation was obviously to reduce the overall latency and also preserve the core network bandwidth and use the network bandwidth only when required, essentially. So that is why operator also gains and the application provider also gains. Right, so operator gains by ensuring that unnecessary bandwidth is not going through, unnecessary traffic is not going through its core network. At IIT Delhi, in the MEC testbed, what we have done is basically looked at 5G aspect, because this is part of 5G testbed. So we have integrated the MEC system with 5G testbed. We have developed an HC compliant. So ETSI is European standardization body, like we have TSDSI in India. So we have HC has its own standard for MEC implementation. So we have followed that particular implementation, and we feel that this system is capable of integrating many applications, including video applications, augmented reality, and other IoT applications. So coming to the next slide. So as we all said, that the idea and realization has been there for 7-8 years now already. So why was this not very feasible in case of LTE or 4G systems? So many people who are involved in standardization and all, they know that the conceptualization of 4G systems started around 2006. First release was around 2008. And MEC, the promise of IoT and MEC started coming in somewhere around 2011-12. So turned out that when the 4G activity or EUTRA activity was going on in 3GPP, it was not very well designed with this kind of MEC system in mind. Hence, there were some issues in integrating an MEC system with existing or legacy 4G systems. Right. So when I talk about 4G system, we are basically talking about the legacy 3GPP EU trans setting. There is even then HC had proposed many workarounds. So you are encouraged to go through this white paper here, which you can see on the screen. So this image is taken from that white paper. So they had one very interesting thing called bump in the wire. Right. So in which case, basically, if you have to at all use MEC in a 4G scenario, make sure that some kind of traffic is opened up without IP encapsulation, without the GTP encapsulation, and goes to the MEC platform. And then this was kind of a hacky solution that was proposed for 4G. Similarly, there were multiple other solutions. So I have given you only 3 figures from that paper. There's 3-4 more figures. So for different cases, there were different solutions which are proposed. And this was all like a post-fix scenario. Right? So 4G system is already there, deployed, and now if I have to integrate MEC, how do I do it? So there were all kinds of, for different scenarios, there were all kinds of mix and match done. Right? This is something which was resolved in case of 5G. And 5G, when it started, their own architecture. So I'll certainly not get into too much of detail of this 5G architecture as such, but all I can say is that it turned out that people who are looking at 5G core network architecture, they were aware of this feature possibility of adding MEC to it, and they had done a clean job of identifying something called UPF here. So if you see UPF, which is called user plane function, that is something which gives a very clean integration point for MEC subsystem. So you can see here on the left hand side, you see 3GPP 5G system, and on the right side, you see an MEC system. Right? So this MEC system does not change with technology. So in case of 4G also, it remains the same. In case of 5G also, it remains the same. Right? If we look at the details of this, so this figure is now almost 7-8 years old. This is the initial HC MEC implementation or architecture. There are many components in it. We don't have to worry too much about that. I'll just at a very high level walk you through some of these components and how we have deployed them in our MEC system. Right. So our objective was not only to come up with an MEC system which runs and shows 1 or 2 applications. What we wanted was that as the whole objective of 5G testbed was that others should be able to use it. This is a government initiative, and others should be able to use it for their own research and all. So one of the key requirements that we had was that we should be able to make sure that any entity, irrespective of their technical expertise, without requiring a significant amount of technical expertise, they should be able to implement and deploy their own MEC application ideas on this system. Right? So that was the objective. So that is why we have kind of hidden most of the nitty-gritties of this from the end users who are application developers. We did need some, we did require to come up with some proprietary interfaces and ways of, there were some optimizations on how to do MEC host selection and all, which is completely hidden from the users. So we have tried to do that at that level. Right? In terms of functional design, we have basically MEC entities roles are well defined. So this is something that Gaurav soon after me will be taking you through. We'll be walking you through this entities, what they are and how they are implemented in our system. Our major contribution has been in defining these MEC interfaces and making sure that they are correctly implemented. And wherever there were gaps, we were able to fill it in and also come up with a end-to-end setup where, for example, here, so this is the overall end-to-end setup. Okay? And in the client side, so this is the client side where your application is running. So this is like your smartphone. The device app is something that we have written. Okay? So because of this kind of translation layer that we have done, given to the users, any company or any entity can write this kind of application very easily. So we have a design document also available. If you have to write an application on top of this, you don't need to worry about anything beyond this. So all you have to do is write a client application, write your own MEC application, and whatever is the cloud server application that you are going to work with. So so that's what whole system is about, and Gaurav will talk to you about this particular architecture in more detail. One of the contributions that we have, and this is being patented right now, is that we are also able to do MEC host selection. So whenever an application comes up, we are able to select the best host possible for serving that particular application, depending on some abstracted versions of the requirements of that application. So application will negotiate with us as to what are the kind of performance guarantees it wants, and we will be able to get the best possible MEC host at that time and run its application there. So this is also the deployment scenario where, so Gaurav will walk you through this in more detail. The left hand side is the user equipment level where the client application has to run. So you can notice that we are not talking about the device application here, because the user, any application developer, does not have to even worry about that. Okay, so that's what we think is a good contribution. And then we will be able to fetch the host application from a server that the client application provides and run it on our MEC host. So this also is kind of seamless for you. So now without delaying too much, I can just say that some of the in-house developed applications are tracking applications where video stream. So this video stream is continuously coming into MEC host. Only when the number of, so based on some criteria, if the number of detected individuals crosses a limit, we let the traffic flow to the end server. So if this is the end server where some kind of policing is going on, or it is this is the end server, which an application which is interested in detecting some event, let us say, for example, the crowd build-up, right? So that event, so this server does not need the continuous flow of traffic. We do that here only in the MEC host. And MEC host, whenever, so it blocks the traffic throughout till it sees a crowd buildup, and then after, as soon as an onset of a crowd buildup is detected, the traffic is led to the remote server, okay, which is the end user of the application. And similarly, there's a face detection application also. More applications will be discussed by Gaurav. And thanks to IDRBT and Wipro, we have few more applications which are very interesting, and we will be seeing the demo of those applications today. Thank you again. That's all from my side.
Thank you, Professor.
So I'll stop sharing the screen.
Thank you, Professor Arzad. Next, we have the demo by the 5G MEC team headed by Mr. Gaurav Shukla, Senior Project Manager at the 5G MEC team. Over to you, Mr. Shukla.
So, am I audible now?
Yes, sir.
Okay. And so my okay. So here's my is my screen visible now?
Yes, sir. We can see your screen.
So I will further be elaborating on MEC testbed setup. So we have different components of MEC testbed here, which is RAN emulator, 5G core, ULCM, and these are several. Right now we have only one MEC host, whereas we have, that can be connected to the HDNN, and then we have cloud DNN, which is connected to the cloud server. And we also have MECO, which is also AF, which is called application function, which connects to the 5G core. So, okay, so this whole setup has been realized in one of our workstation here, HP Workstation. So you can see now, you can see all the, I just want to focus on this picture. You can see this client tab, device app, and G.B emulator. So these all are running on the same machine, whereas 5G core is running on one of the machines here. And again, the ULCM is connected to the 5G core and through MX2 interface. And ULCM and MECO interacts with MM9 interface. And MECO is again connected to the 5G core. And so basically, MECO is also called as the application function because the 5G core, as Sir has said, the 5G core gives more advantage of having to use the MEC edge computing. So that is because of the service-based architecture that it is having. So application function interacts with the 5G core, and there is one of the this NEF is the network exposure function, where we can send all the information from the application function related to the to connect it to the edge level computing or edge level, or we can say MEC host. So in the diagram you can see this whole thing is connected up to the cloud DNN. Whereas once the traffic influence subscription, once we select the through MECO, we select the host. Okay, so if we select the host, we do the host selection here at the and we send the traffic influence subscription to the 5G core. So the traffic from the client application is then directed through ULCL, UPF, and then UPF to the HDNN. So to the selected host. Okay. So this is how this whole system works. This MEC testbed setup works with the in context of the MEC. I mean, definitely there are multiple more nuances, but if as a application feature we talk about, then this is how it works. So I'll show you this is our workstation. Okay, so these are different components, as you can see the different apps. So we have set up this whole 5G this MEC setup with the integrated with 5G core in this workstation only, with different virtual machine as the different components of the MEC. and the 5G core as well. So likewise, as you see, this is okay. So these are the different components of, like, in the diagram only you're seeing these are the components: AMF, SMF, PCF, NEF, NRF, UDM, UDR, AUSF. Just a minute. Okay. So so these are the different components that are there and that have been realized in the 5G core. So you can see NRF, AMF, AUSF. So this is the 5G core. And then we have RAN emulator, as you have seen. This is the RAN emulator where different this is our RAN emulator that is running. It's a work of combined work of Civit and IT Bombay. And then we have this device application that is also running here. So all has been written in Python. These servers are already running there. So I mean, time doesn't permit to actually to start all these things and to show the setup, but these are all already there running. And then we have ULCM, there also the server is running, and we have ULCLH, where this see this ULCL edge is also, this UPF is running. And then so actually during the time we were having a separate server, but at the time of COVID it was very much needed to have a single machine to because of the working from most of us are working from the home that time. So it was very much needed to build a setup like this in the virtual machine environment where all this setup is at a single place and we can work on it at any given time. So that was needed. So this whole machine shows how the setup has been done. So because so once the RAN emulator starts, connects to the 5G core through AMF, and then it connects to the cloud DNN. Once we MECU, it also connects to the MECU. So once we run the application, once we select the application from the MECU, do the host selection, then we send this traffic influence subscription to the 5G core NEF. So NEF gets the traffic influence. So this host has been selected, and this is the information about that host IPs and all that information is there. So MECU now the once this traffic has been transferred, now the traffic coming from the RAN emulator, if it is also directed to the MEC host, the selected MEC host. So client application then can directly connect to the so MEC this client application then can directly connect to the via ULCL edge UPF. So this is the path, and this is the I mean it is connected to the MEC host. Now I show you. Now I move to further. So client application. So building a client application, device application. Client application, edge application, and cloud application. So we already have one application running. So we have a simple application where we this is a text extraction for in agriculture domain. So like I have so we enter the text from the client side, it gets extracted at the at side, and then it is whatever be the string is there, whatever be the relevant keywords are there, that are be transferred to the server. So that application is already running. I just show you, and then I'll convert this client application. I mean, any client server application can be converted to client and can be converted to client and a server application. So that I'll show you just now. So this is the application that we are running. So we have like farmers are So like if I say farmers are keeping the livestock. So once I send it MECH, it determines if farmers and livestock are the keywords, and it sends it further to the server. So these are separate applications that are running now. Now suppose we have to convert it to the as a client application, edge application, and cloud application. So this application that is able to run on the 5G. So I'll show you how easy it is to convert this simple application to our MEC system. So right now I'm just okay. So so what I'll do, we have a, so I will just within a minutes we'll be able to convert this application to a application that is running on our testbed. So these are separate applications that are on different machines only. Now what I do, I go to the, so this is a setup of so this is our client side where our Gnode B is running. It is ran emulator. So here we have okay. So client app basic. So we have developed a basic. It's a basic setup. We just copy it here and then paste it here and then rename it as new application. So suppose now we have 333. We rename it to 444. Okay. So our client application, our client side application was somewhere here in this Edge client basic. So this is the text recognition client. So I just copy this application and paste it here in the 444. Okay. So this is what I have done now. Now in the configuration file, I have to make certain changes in the configuration file to set the parameters. Okay, so this is let's say this is text recognition, and provider is IT, and the software version is 1. This is text extraction in agriculture domain, and so this is let's say vendor ID is let's choose some word 561. Okay, and this is not needed actually. This is not much needed. So just making these changes. Now our client, its deployment at the client side is complete. Let's save it. Okay. So now we move to the edge also. So in the edge, we have so in the app store, all the edge side applications are there. So we copy this. We have already a basic. So basic means there are some parameter files and the configurations file that are needed, that are already there. So we created a basic folder with that, and now we copy it, we paste it, and then we rename it as 444. Okay, so we name it as 444 now. So I go inside. So here where our Edge application was running, just copy it from here. This is distribution. just paste it here. One more file, that dictionary is needed, so that also we copy it here. Okay, so we change this, rename it to 444 now, and then rename it to 444. So all the required files are there. This text this is not complete. So config. So I make some changes here. So this is app command is Python. I think Python only will work. Script app guard. So these are the application that are needed to start, the command that are needed to start, and the file is extraction. Test recognition as well. And so rest all file will remain same because we are using the same MEC host right now. So rest of event they need not be changed. Okay, so we save this file. Now all we have to do after this, that we have to keep this the entry at this. So we have to make an entry in the MECO database to get this application registered. So this is 561 vendor ID. This is text recognition. So, just a minute. So I'll just make it here 561. Text recognition. This is 444. Application name. Text recognition name. So I make this entry in the database now. So that entry is there now. So 561 is there. Now I simply have to go to the RAN emulator and go to our, from where we will initiate our application. So we will go to C. And then I run. So this is supposed to work, and so we already have this application loaded here at the. You can see now this application has been loaded in the MECH our edge host, and this. Okay, so this is our client edge. So now here again, and the cloud is already running there. So if we now enter some more, like, so basically cloud is keeping track of all the dictionary of the keywords that have been used and keeping a counter over it. So most relevant keywords will have a relevance over the other ones. So like again we say farmers, livestock, so here you can see these farmers, livestock, acres, land, these have been extracted and be sent to the cloud server. So the counters have increased. So this is a simple application. I mean, application was simple. So I just wanted to show the deployment here in the MEC Testbed. So this is how we can easily within a minutes. I mean, there are certain more nuances, but I mean, it's so easy to convert a client server application and bring it to our MEC testbed. So it's we have given as much possibilities, as much making it much more easy, because everything has been taken care of with the certain parameters. We have device application ready, everything is there. So we making certain changes in the parameters, and any client server application can easily be brought to this MEC testbed. So this is it now. I think I'm also reaching my time. So I show more applications now. Okay. So right now I'm just closing it down. Okay, so so deleting this application. Now moving to another application, which is G45, which is face recognition application. So if we start, so I mean, this is how we have developed different client server applications in our testbed. So I said, this is one of the application where it streams a video of and I myself and Shashwat are there. So it actually it relays a video here to the edge host, and edge host recognizes the face, and is to a certain person. If a certain person is detected, it send it to the cloud. So let me also start this server file. So this is cloud server where this is running. So as soon as it detects Shashwat being in the frame, I mean the other person which triggers MEC host to send it to the cloud. So right now there's nothing there in the edge host, whereas once the Shashwat is come, so Shashwat has been detected as 2. So now Shashwat has come, this will start relaying it to the server. So Shashwat will get relayed to the server, whereas mine doesn't. So it's one of the use cases. The other application that we recently have developed. So I will close this one. How much time do I have? So I think I have 2, 3, 4 minutes more. So I can close it from here. So now I show one of the application that is being deployed from one of our contestants. Okay, okay, so this is one of the application that has externally developed by external party, and we have deployed it here. So this is similar to that one. Okay, so here this ATM, the person moving to the ATM counter, and it detects I mean, more than desired person are there, then it triggers the alarm to the server. So I just on this class. So basically, so here they are relaying this video, whereas it's been detected here in the edge host. So this is the ATM machine that has been detected. It takes a little time. It's a bit slow reaching to the frame speed. They have made slow to detect the person correctly. So more than 2% are there, then it triggers the alarm to the server. So still it has detected 2. So once it will detect more than 2, it will trigger the alarm here in the one of the application in the cloud server that you have. So sound may not be audible, the alarm beep may not be audible, but we also print the message here. So once so like we have person counting, person counter is there that Professor Azad had shown there. So we have more application, but time doesn't permit us to show all the application. So we'll show the most. This is one of the external application that we have deployed in the MEC Testbed, and it was deployed in within a matter of minutes only, because they have it was similar application like that. So now you can see that this more than 3% detected chances of fraud or crime on the scene and playing alerts. So these are the applications that are there. One more application I can show, and then I quickly wind up. Okay. Let's close this application so that all the logs that gets deleted at the MECH level. Okay, so there is one more application. So this is one of the application where I just developed working from home. So it actually detects the gender. So I've been relayed from here. My video has been relayed from here. So it detects at the MECH level, it detects the gender and the age. So once the correct and again once the person's age is detected, like mine age is detected something between 25 and 32 and the male gender. So it relays a video to the client for something. I mean, so this is one of the our use cases, and you'll see later on once the one of our contestant will show the demonstrate the similar application with much more scalable level. But this is one of the prototype of that application. So once the age is male and age is detected, it sends the it relays the video to the screen relevant to that. Now let me let's see. So again, so okay, once this video is over, it will again send detecting the age of the person. So right now it's sending the same video for the younger people. But once it will detect, once this video is over, it will broadcast video for the kids. So now the age is okay. So it will again send a video. So now seeing the kid is there. So the idea is that once you go in the mall and the person is detected, the kind of person that are entering, accordingly it plays the video in the on the screen. So now the kids will have their videos on the screen. So that's a kind of it's a small application and it's trying to simulate the uh, bigger application that you'll see in the later presentation. So I think it's my time now. I should. So Pimmi, thank you, and thank you all.
Thank you, sir.
Now you can move to the contestant now, and thank you all for bearing with me. Thank you.
Thank you, Mr. Shukla. As already stated, we have shortlisted 2 teams who will now be putting up their application demos. So first of all, I call upon the team from IDRBT Hyderabad. From IDRBT, we have Mr. Kiran Kumar and Ms. Parthavi, who are research associates and working in video analytics. I request Kiran Kumar to please start presenting. Yes, your screen is visible.
Yeah. So good evening, one and all. Thank you, Pimi. So let me start the presentation. Okay. So our idea was to demonstrate a video analytics in banking sector. As we are from IDRBT, we provide solution to bankers so that what are the new technical technologies that can be applied to their one of the applications so that they can have a secure they can have a better experience with their applications, and so that the clients can be um, uh, have a better experience to what they are providing. So moving on, one of my couple of my participants are myself is M Kiran, and I'm a RA from IDRBT, and Parthavi and Balaji. So basically our application overview, thanks to Gaurav sir. Pimi, can you hear me? Hello?
Yes, you're audible.
Yeah, okay. So basically our application overview would be like three aspects. It actually concentrates on 3 aspects, like blocking an CCTV video feed, so that if there is any fraudulent thing is happening within an ATM premises, that might be the case where it alerts to the concerned authority, just like what Gaurav sir has just now showed in their test bed. So one of the use cases that, and also if there is people who are staying in the ATM premises for a longer period duration of time and staying suspiciously, that might be one of the use case, so that it can trigger an alarm. And also, if there are a group of people, whether we don't know whether what their intention would be. So if there are a group of people doing transaction in ATM, so that was one of the cases that we have tried to include in this use case to trigger an alarm and notify to the concerned authorities. So that was our overview, application overview. And then coming to our design. So first, our setup would be like set view first an ATM premise, ATM center, where we have a ATM CC camera feed, and then that CC camera feed would be transferred to a edge node server, and then the edge node server does all the processing thing, and it detects based upon the model that we have chosen. It actually does the job for us, and uh, whatever the detection part or whatever it has got out of that video frame, that actually goes to the database, so that tomorrow if anybody from the banking sector or a banking representative want to take a look at it, they can actually have a view on that. So that was the idea that we have come up basically. And this is what the complete design looks like. It sends the video frames to the edge node, and then based upon our training data and the model that we have choose, it can either go alert to the concerned uh, authority for the immediate action that can be taken, so that uh, bank is safe and secure. So this is a basic design. And the technical aspects that we have considered for this application was like we use Python, and the framework that we have used is YOLO v3. I know there are a lot of other frameworks that are available um, in the in the technical world, but we have used YOLO v3 specifically because it is more reliable and it is more accurate when compared to the other models like fast RCNN, fast RCNN and RCNN, and there are other models like SSD, everything. So, but this is more reliable and more accurate. So that is what we have gone up with. And also the other libraries like OpenCV, and the one of the component that we have used was darknet component, which is a part of YOLO v3 contribution itself. And for annotation tools and everything, we have gone up with YOLO mark for annotating the data set. Basically, we have huge number of data set for training, like 2400 images, and we have trained it on a high machine, and so that was it. And coming to the actual application workflow, as Gaurav sir has already shown a demo on the test bed, but to give an overview, so this is what we have tried to uh, do on the test bed. Like we have a client application where our VLC media player is relaying our video, and it goes to the edge node server, where our script actually the main script does the job, which has a custom weight file and also the config file. The custom weight file is the file that we have got it from YOLO v3 after training around 2400 images for about like 12 hours, and that is what we have got. And the configuration file same as like YOLO, but little bit changed according to uh, our requirement. And after the script runs in the edge node server, the alarm goes on. If there's any suspicious activity, that there are more people living in the ATM premises, it might give a alarm message to the end server, where we have a flash server that we have set up, and it calls upon this alarm message triggers this server, and it shows the message. Just what have we have seen in the test bed itself, shown by Gaurav sir. And basically, our features are not much, but these are the few features that we have detected like for fraud detection, that just now what we have seen, like real-time alerting messages to the concerned authority and accurate. So when compared to our model, it actually based upon our training, it can actually detect on an average of like 75 to 80 percent accuracy, and it's quite good based upon the training that we have done. And we have trained only for the 4 classes, that too only for 2400 images on only 4 classes itself. So in future we might go ahead with more couple of classes so that we can have more use cases in future. So in this application, we have 3 scale detection. Because of this 3 scale detection, we have got the most accurate object detection part. So this is the only best feature that we have in YOLO. That is why we have chosen this model, so that we can have better accuracy, so that we don't rely on any sort of mistakes. So, and basically our application is very light, and it's kind of easy to use, so that it won't have any issues using it. So these are the features, and these are the performance graph that we have. This is chart that we have got it from training our model on the images. So as we can see here, we have 2400 images with a batch iteration of 8000, and we got a average loss of 0.34, which is very good. So this is the only reason why we got the best detection part. So this is the chart, and so this is one of the demo snapshot that we have captured from the demo. So as you can see here, this is one of my colleague that who works in IDRBT, and also this is one of the ATM that we have procured from the Vortex, and it actually is procured and in our IDRBT museum. So we have captured multiple video files, so that we can do this kind of yeah. So this is one of the use case where if a person stays longer than the time duration, this is how it triggers the message like time limit has been extended, and this person is staying in the ATM premises more than what he's supposed to do. And this is one of the use cases that we have. And also, if there are more number of persons who's entering into an ATM, and one person is doing the transaction, so this is how the message tries to alert to the concerned person. And also there is one other use case that we have also used, was like block. If a certain person comes into an ATM and blocks an ATM camera, then this is how the message pops up, like someone blocking an ATM, please do take care of it. So this is one of the these are the couple of use cases that we have gone through. And also there are other use cases that we have tried, like if a person comes into ATM with a weapon or something, even that has to be done, but it is not that accurate. So we try to leave it in future, so that it might work better. So for currently, these are the 3 use cases that we have come up with. And also there's a video, if you want I can play it over here. So this is a ATM premises that we have in our museum, and this is one of my friend colleague who's actually doing the transaction. And you can see there's the accuracy more like 90% to 100 based upon our training. That is pretty much good. So this first video, actually this is a combination of all the 3 use cases. For the first video, first use case is to detect if a person stays more than the time duration, then it has to detect that time limit has been extended. you can see the time limit has been extended. This is one of the use cases that we have. And later on, there is another one where if more than 3% come into the ATM center. So these are the this is one of the use cases. So here you can see that more than 2% exceeded in an ATM. This is one of the use cases that we have. And later on, the next one is the blockage of the video camera, where we have tried to add a alarm beep message at the end if someone tries to block the ATM camera. So this video is also detects the time that we have set it up, and now my friend, one of my friend would be blocking the camera so that you can hear the probably the sound is not coming out, but so those are the 3 use cases that we have worked on, and currently more to come. So other 2 use cases are like carrying a weapon within an ATM, and or trying to hit the ATM so that a theft has happened. So those are the other 2 that we are working on, and for future research, what we are trying to do is like if there is a person who is doing some suspicious activity in an ATM, we try to set up a IoT sensor where if that happens, I mean the theft happens, the ATM shutters go down so that the thief might not escape, and the respective authority people can actually find him soon. So that was one of the future research work that we are looking into in IDRBT, and also we are looking for the other use case like behavioral analysis based upon the person's behavior or action. We want to detect what his intention is, and then detect to the inform to the concerned authority for what he is actually trying to do. So these are our future works, and for that we are doing our research. We have a team over here in IDRBT, and we are looking forward to make it happen. Yeah. So that's it from my side. Thank you for giving us the opportunity. That if there's anything that we can discuss.
Hi, Kiran, this is Manish. I just have a quick question, 2 questions in
Sure.
fact. Well,
Yes.
IDRBT is, what kind of organization is this? What do you guys do?
Sir, basically IDRBT is like
this is Abhishek
Hello?
Thakur here. Kiran, if you don't mind, let me take this.
Yes, sir, please go on.
Yes, so IDRBT is an autonomous entity established by RBI. We are primarily researching in banking technologies, and of late we have also started working with 5G use cases lab as a vertical specific application area. Part of the work that Kiran and team have done is also contributing to the lab.
I see. Okay.
There is a small autonomous organization, roughly 30 people, working in collaboration with multiple institutes.
Okay, fine. So, but most of the people are here are what, the postdoc research, what kind of people who?
So we are 14 faculty, counting our director who recently moved from IIT Madras. Professor Janki Ram is our director, and we do have 30+ PhD students in collaboration with, say, IIT Hyderabad, University of Hyderabad, NIT Warangal, Trichy, and IIT Madras.
Okay, so let me get to my question. This is something I just wanted to enlighten myself on, what organization is it. But my question to the team is, why do you think this is a right application for to be hosted on an MEC platform?
Yeah, I would let the team respond rather than me. I can come back later if needed on wider perspective.
Yeah.
Yeah, sir. This is one of the application. I mean, like idea that we have discussed with the professors from IIT Delhi also, so that what can we come up with. So the idea was to was to nowadays there are lots of robberies and thefts that are going on, so in ATM. So this is one of the approach that we have tried to come up with, so that the
No, I understand, Kiran. The use case is understood. That's not a problem. I just want to understand, why would you do it on an MEC, right? This does not necessarily need an MEC. If you were to see today, this is being deployed, this is being built. Why did you choose that, this should be done on an MEC?
yeah, sir. The reason would be like the quick response and 5G, as we are talking about the low latency and the high bandwidth. So with video analytics, we can achieve that. So previously, it's not like this is the new idea that we have come up with, but there are lots of other applications or other ideas that already couple of great people have come up with, but we thought like this application should be on this the MEC testbed, so that we want to make it work like how it actually comes out of it. So that is what we have.
Did you measure, if you were to do this application without MEC, what would be the, say, round trip delay? And if you're doing it on MEC, what's the round trip delay? Did you measure that?
Yeah, sir. We did try to measure that, and in our lab setup we have tested it out. So when compared to the MEC, the the application that we have tried to run it on our machine is quite low, and when compared to the MEC testbed, we can see the change over there. But still, we want to make it more accurate, more better, so that the response time would be more less. So that is what we are targeting. And hardly this application was like developed and built in 20 days, to be frank. And thanks to my team who put their efforts in this building this application. So we did work really hard on this. Yeah.
Okay, thank you.
Yeah, thank you.
Any further questions?
So basically, same question as so latency, because when you're saying that you are measuring the latency, means it is basically on the host machine and other thing, but the basic idea of MSC is that the round trip time has to be very low. So what makes this particular application feasible for MEC? That is the same thing.
Yeah, so one thing I'm adding here, please don't take it in perspective of the team. It's just for the wider context why we are looking at MEC in these scenarios. One is we do not want to deploy more hardware at the branch or ATM sites. If connectivity helps us do things, that will be an added plus. Second is, though the demos are single camera feed, we foresee multi-camera feeds being analyzed simultaneously. So multimodal analytics and other things will come into play. Wherein edge can actually reduce the amount of data that we have to send back. So ATM site is a good example. Even in future, we are looking at continuous authentication of branch staff and similar, so that once they are authenticated, we can track them within the camera preview and have an optimized experience for the staff itself. So there would be more scenarios like that, which will help define next generation banking and financial services.
Yeah, my only counter question to you would be is that there are many cameras nowadays available which give you all the analytics right on the camera itself. To be able to reduce your bandwidth requirements, that can also serve. So there has to be a stronger reason why it has to be done on the MEC. There
Right.
is
So
one.
if we have more than one
And
feeds,
what you have been thinking about. Sorry, go ahead, please. Sorry.
yeah, so the idea is multi-feed. If we have more than one perspective, including IoT and multiple camera feeds, each individually may not be able to give us the value addition that an edge optimized solution will be able to give us.
Thank you, Parent. No more questions. Sorry.
Thank you, team. Heading forward, we have our next demo from Wipro. From Wipro, we have Mr. Nanda Kumar, consulting partner at Wipro, and Mr. Apuru Kalapala, technical consultant at Wipro.
Thank you, Mimi.
Over to you, Mr. Nanda. Please carry on, Mr. Nanda.
Hello.
Yes, we can. Yes, your screen is visible.
Yes. Hey, good afternoon. Good afternoon. Good evening, all. To all the juries and professors there. I think it's a very good informative discussion today. And I say I'm Nanda Kumar. I'm part of the I'm a consulting partner, and we part of the Wipro CS CTO team. So Wipro got a huge huge organization. So we are one of the cloud infrastructure services organization where we have a department of 5G and other various verticals working on this. Okay, and my colleague Mr. Apuru Palapala is a technical consultant. He works with us very closely on this in building up this product. And we have a partner also. I mean, we try to include him. Is Saurabh Joshi from Aleph Edge. There are one of the edge compute applications providers for various applications. And we have the technical team of Kushal Ranmale. He's a part of the Aleph Edge. First of all, it's thanks for providing opportunity to work on this. I mean, to come out with this. We come out with the two solutions today, two use cases, which is a business ready use cases. We built up in our lab. So I take a few, just 5 minutes, 2 minutes on this. You can see my screen. See, we have a technology center in Bangalore. Okay, in Electronic City, Bangalore is in our Electronic City, Tower 14. So where we have a state-of-art built-in innovation lab, incubation lab, basically built on basically it's set up by the CTO Technologies, our technology group, where we showcase various various innovative use cases there, conceptualized use cases there. So emerging technologies, digital industries, digital industry process, digital native consumers. So every this is open for all the our customers, globally existing customers, as well as the visitors who come from the various countries for the understand to knowing what is innovative use cases, what Wipro has built in. And every year we have further customers globally, and we have some we have almost CSO, CXO and senior management will engaged in a lot of meetings. It's all complete experience, customer experience delivery. So what we focus more on, recently we started, last recently, maybe a couple of years, we started on the 5G MEC use cases, where we build with the partners. We implement in the lab, we showcase live to the client. This is actually what we are doing. We already developed, so because basically it's Wipro system integrators. So we coordinately work with the various OEMs. We collectively build the use cases and we make it ready for the implementation. So various use cases now in the lab, you can see even the here we have a lot of cases are there. We have a smart face case are there. Industry we are there where the remote maintenance, remote management. You have a complete queue deployment there where we can see a live a virtual review all is available there. We have the robotics drone drilling live. and all live scenario we can see in the thing. It's a 1 hour walkthrough in our lab. I request team, if anything, then we'll try to arrange a 1 hour walkthrough. Apart from this, we have a lot of immersive zones. You do maker of labs. We create a prototyping of we do fabrication of robotics. We do testing, deployment. These are some small thing I thought of just putting across before going to my presentation. Thank you. See, first use cases. What we want to deploy is basically a video enablement. I think video enablement. You can see basically it is for the providing the high bandwidth videos, HD videos or even videos. These are the various things what we want to basically streaming technology what we used in economies of partners. See what actually is challenges we face here. Basically, I go to challenges. See, basically we can see that no video intelligence available here initially. I think so. What happens then if there's no intelligence there? I think we don't get a real-time upstream and downstream videos. And second thing, the processing, lacking of processing compute. Because of continuously rise of data consumption, our network gets choked. And third is more important thing is on the security. I think nowadays a phishing attack and we can send Zoom bombs or other common level of security we can now oversee that. So what actually outcomes we come up with from these applications? From the application and from the application overview, what we present is video intelligence for real-time decisions. It gains, what means it gains a new intelligence for upstreaming and downstreaming video to create a real-time actionable insights. So that's one of the key part of this. And even it has got coming out of security also, anywhere 5G grade security, because it's a comprehensive 5G grade security for immersive video applications. That's actually what we want to plan on this. So if I run the overview of things, it's a edge-powered media streaming. Basically, when you talk about our recent 5G technologies, various categories, we work on URLs categories where we install or we integrate our applications to the to a telco operators or to the enterprises teams or any of the private network teams where streaming next generation streaming platform will be there. For a long platform or live platform or social videos, all content advertisers, all things can be streamed through edge. So how it is, we just won't explain. So it's an application, micro-black application sit on the edge network. We're showing various ranges of features. Channel switching of depends upon the whether we are uploading from streaming from the cloud or streaming from the edge. We can see the differences. And even streaming up from the edge creates a lot of new opportunities for the content owners, like high definitions, interactive, immersive contents, by using a smartphones. So some of the key benefits I can say is our high resolution video delivery content, zero start time. That's more important in the thing. And coming up, no buffering, can see no buffering, and then notifications. Some of the business model we are going to include in this. This is one of the basic concept. See this. What I'm talking is all setup available in our lab. This use case what we developed, we collaborate with couple of vendors. Various vendors like this particularly is worked with Wipro, collaborate with VMware and with the Edge partner, our LF Edge. So we created a complete setup in a lab. We can see the setup. These are the 3 servers, x86 servers, where actually we install the applications there. We run the various applications, we deploy various applications there. It's all center management. This is called Edge node, where our complete action happens here in the Edge node. Where presently, since we don't have the 5G environment there, presently we're using some Wi-Fi for doing these activities. I think maybe next couple of years, couple of months, I think we set up our own 5G network because we got approval, other things and Wi-Fi approval, things and all. We plan to set up there where you can see live use case. Not only that, this is one of the simple use cases I'm talking about. We have various use cases with the various verticals. Even we have in retail, in media, other things and all. Coming to some of the silent features, approved. Silent features of this.
Thanks. Yeah. Thanks, Nanda. You're able to hear me, right?
Yeah, go ahead, go ahead.
Right. Yeah. So this particular platform, the edge-powered video streaming application, right? So it's a secure and intelligent and manageable platform that sits at the micro backend. So the content providers don't have to worry about the network or the underlying infrastructure. So they have to concentrate on their content, and yes, they have to get their competitive advantage for providing the content to the customer. Depending on, it can be various use cases. It could be use case of a retail mall, or it could be a sports stadium, or it could be an airport, right? So depending on the kind of vertical and kind of feature that is being consumed, yeah, so intelligence is there to drive that media streaming technology. So some of the existing technologies which can take advantage of this is video on demand. So features like your Tata Sky on demand, so your Tata Sky on demand, or things like your HBO Max, or Disney Plus, right? So they have on-demand video movies that are available. So that can be provisioned through it. Second is stream processing. So lot of use case scenarios like your thermal imaging cameras, right? So they require real-time analysis. So if a thermal imaging camera is doing the analysis, it doesn't need to go to into a cloud. It has to be processed, and yeah, the results have to be given that this person has a high temperature, and yeah, during this COVID times, right? So that is a very important feature that is required by especially these airports and railway stations. So that is one of the use cases. Then is the live streaming, right? So as nowadays IPL is going on, and Disney Hotstar has around the peak concurrent users has touched around 25 billion users, right? So this is also something which can be leveraged through this platform. And then you have collaborative platforms, right? So nowadays a lot of manufacturing companies and even the telecom site providers are using AR-based remote management services, where AR is being used for doing all kinds of field maintenance activities. So all kinds of notation of on that particular instrument, or if there is any activity that needs to be troubleshooting activity that needs to be carried out, if for auditing purpose, right? So entirely the remote assistance is provided through AR using that video. And also there are some drone use cases where the surveillance or the maintenance monitoring is being done through drone. So even drone has multiple use cases, and the camera that is there on the drone, that is being fed to the nearby edge center, right? And then you have video notifications. So a lot of push notifications are being embedded with video, and yeah, so content is pushed to the to the customer. And then you have interactive video messaging applications like the GoToMeeting that we are right in. Then you have Zoom teams, where multiple organizations and their team members are collaborating with each other, and there is a lot of interaction is being done. And then there are other applications like your house party applications, and then there are dating applications where the customers are interacting with each other, right? So they are having a lot of social gaming is happening, online gaming is happening, which requires real time interaction and yeah, features that needs to be implemented. And coming to the newer products, right? So we are looking at OTT content. So Nanda, can you go to the previous slide? Yeah, when it comes to the OTT, right? So they are enhancing the OTT applications with other interactive features. So there are interactive movies that are coming up. So that will actually branch out the storylines, and that is also being provided at real time. And then there is video crunch of very short videos like TikTok, Instagram Reels, YouTube Shorts that are being consumed. And then there is My TV personalized AI TV, which is being provisioned by which are being enhanced by OTT applications like Netflix, Prime, Amazon Prime, Spotify, where their expertise is on the recommendation and suggestion for the customer based on their browsing history, their interest in the genre, etc. And then you have car TV, bus TV, train, aeroplanes, where through the screens data media is being consumed. and then you have enterprise applications, and you have VenueTube, right? So VenueTube refers to your keynote speeches, conferences, stadiums, concerts, where the real-time video is required only at that particular location, and not every audience is available at each of the location, right? So they can consume that particular media as well. And then you have smart surveillance. Smart surveillance will be able to do the video analytics. I think in the by the previous team also showcased how smart surveillance is going to be play an important role in not only in the financial sector, right? So a lot of use cases, airports, etc. It will play a huge role. And Venue Replay will showcase the fan engagement aspect. It will bring into their screens, right? So some of the examples can be a camera that is there in front of on the helmet of an umpire, or maybe on a goal post when a footballer is in football there is a goal post, right? So the camera can be there, or it could be in front of that Formula One car. So that gives an additional fan engagement experience for the customer. And obviously you can monetize all these aspects through advertisements. Obviously you have the data of that particular customer, so accordingly the content providers can customize and provide the media streaming to the customer.
Yeah. Okay. These are the basic, some performance what we analyzed as per the data available and what we experienced in our lab also. So this which way where benefits the customer or benefits the business users. Like when you check out, we'll show practically. We'll show the video how it works. But to just for a to brief, it is around if you see HD videos, like it is compared to 2.x better than the what actually you want to do media is applications. I mean 6 times better than the resolution doing advertisement applications. And if you download the huge files files from the MNO then directly from cloud, or then check with the edge, what's the difference. It's a very large percent better than this. 80% we can see the difference, and comparatively we can see the resolution of the virtual applications. Now we can see it is 1.5 or 4 times better than this. So these are demo shots. I will show it. I mean, what I experience is, for example, see how we show how the edge works. That's the concept of what we created there, right? Like normally when you start downloading from the MNOs like mobile network operators. So what's the downloading a small downloading an image, what the time takes place. Same thing when you stream from edge, what the time takes place. That's a demo we are showing. Similarly for the same thing for the videos, what are the parameters involved in this? How it enhances the enhances the quality and the performance that we going to show for this number of KPIs. These are concluding remarks. I think basically with the rise of 5G environment, I think video enablement plays a major role for all the networking computing, particularly for the enterprise networks, and for the private networks. So, and also we are doing some area of innovation, edge automation. We are doing actually some going on, upgrade automation going on, some edge routing for different kind of other use cases. Even the app enablement, even edge mobility are there. Edge roaming things are doing. So coming to orchestration level and elasticity, that's a thing what actually we are there. So I'll quickly go to video. So it gives you heard about it. Let's have a video. You can see really how it worked on this. I'm running a video. It's a silent video, but I'll just run it. This is a small video. I'll explain initially. We have 2 images here. One image is from the cloud. For example, I'm using my mobile where my app is there, where I download something from the cloud. What is the time taken? What is the clarity? Point number 2, second image. When I download from the edge, what is the difference and what is the quality? That's a demo what actually showing. So we're showing what's enablement basically at the edge. This is, for example, we have 4 options. One is called edge to cloud river. You can see the timings down, image response time. It's taking 4, 5, 6, 7. It's basically 45 MB image. 13 seconds, 14 seconds.
Just to iterate, so on the left-hand side, the content is being loaded, the breakout is happening, and the content is being loaded from the cloud. And on the right hand side, the content is it is being fetched from the edge. So that is what we are trying to showcase in this demo, right? So the response
So
time on the cloud, you can see
yeah,
it is around 21 seconds, 20.7. And Munanda, you can put it on full screen.
yeah. That's what I'm just saying. You can see that we marked here, it is 20.7 seconds. When actually same thing we've streamed on edge. So what's the difference we can see? The 45 MB image, what the time it takes? It takes 1.52 seconds from downloading from edge, streaming from the edge. This is what we need to just to clarify that how the edge plays a vital role for all the features what we want to explain. Similarly, I'm talking about on the image. Let's talk on the one small video also. We can see I can give all the parameters. It affects the performance of the videos running through edge. I'll show you that. We take a small edge train, moving, cloud train moving from this. You can see this. The train is moving. I'm rolling from normal GSM operator, normal cloud listing. So you can see KPIs here. See, duration of the video of watching is it's showing 37 seconds. Duration of video playing is 7 seconds. Video startup time is it took 3.2 seconds to start up. Total stall time is 8.5 seconds. Buffering happens here. No buffering happened. That's the second stall count, the buffering count here. And what is start is telling index 2.0 index. So this is when we start streaming from the cloud. So complete information I can get. What are the KPIs of that particular video stream we rent across. So it's basically 38 seconds. See, duration actually video is only 33 seconds, but it took 54 seconds to run the video. You can see some stall points here. We can see the total, 4 bufferings and 16 stall points. Same thing, if you went through a cloud, you can see the difference. Edge box or edge system, you can see the difference. You can see the video KPIs. So 35 seconds, 0.11 second video, it played in 31.88 seconds total watching time. And you can see, sorry. We can see the startup time 7.7 seconds, no stall count. So no, streaming has been perfect. So this is one video what actually we just want to demonstrate. In fact, we thought of demonstrating in MEC test lab. Unfortunately, due to the pandemic, other things and all, we're not able to go to the office. Still we are working from home. So that's one of the reason we not able to work. So we created a demo and we just showing this with other things. This is one more video where the 76 MB a PDF file, HD video file with downloading also. So just I'll show one only this. So it took around taking around 22, 20, 24. It's 76 MB file actually. This all tested in the lab, proved in the lab, and we recorded there. So this is the file actually. This is one of the I content file of some of the historic images. Okay, so you can see it has got high density images. You can focus. You can do all those things. Okay. So same thing when you edge on the edge compute. So it takes around 2.5 seconds. So that's where we can just we can really show how the edge element works. Similarly, we have the I content. It takes more videos. And one more thing I can show it here. It's a lack of time. I don't know all the videos for a long time. One basic thing you can see general images. When I saw small HD image. which is around 2 MB, 3 MB. Not much also. That's use. It's a 7 MB image. It takes around 2.8 seconds in the when you develop a cloud. Same thing when we streaming from edge. It hardly takes 0.6 seconds. So this is where I can just we can see the comparativity, this thing.
Professor, just to iterate, this is not a CDN that we are proposing. So CDN will work on the principle of supply and demand. So it will have multiple regions across the country or depending on geographical location. So this platform is something which a content provider can customize and provide a contextual content based on their demographics, right? So they will be and their interests and other data that is being collected. And based on that particular content is pushed, right? So all your OTT applications and so all kinds of media streaming can be pushed to the customer, and obviously you can manage it from the back end through so all your how the content is managed by the aggregators, right? So that can be managed. You can have a real-time bidding for these kind of content that can be pushed depending on the use cases, right? So that is how this is differentiated from a CDN. Yeah. So that was it from our end.
This is for the one use cases what we proposed or what we want to showcase.
Nanda, are we having questions on the edge enabled?
Finishing this, I don't have always questions, so that no one's for all. Or you can I can take questions on the video element. Our team is there.
Yeah. So my question on the video element is that basically you are showing that the advantage of edge for the video delivery. That's the thing you are showing in this. But how the video is coming to that edge, because naturally, means if it is edge delivered, it will be low latency. That is well known. But my question is that like OTT application you mentioned, and you mentioned CDN. So how it is interacting with CDN, because the actual delivery is happening to CDN, but how the video is coming to the edge. And in the case of live, how you are managing it?
Kunal? Kaushal? Kaushal is there? Yeah. Kaushal, you can speak? Okay. I think he's our team member. He want to take a call. What is? Hey, Kaushal is there? Yeah.
Can you hear us now? Am I audible?
Yeah, audible, Kaushal. Go ahead.
Yeah. So the way in which our edge proposition works is we have a specific component which is application processing, which synchronizes with the content which is in a cloud, and on demand or with real-time basis, with the real-time bidding happens, and whoever wants to send the content to our edge site, based on highest bidder, we push that specific content to the edge side, and user gets the enhanced delivery of the content. That is how that is how our application or stack has been developed, and it's working in this way. And that is how we are able to give you such a ultra low latencies and high throughput.
Yes, sir. This is where actually in lab I showed, in lab environment, this is a central management cluster where the bidder from the or the content provider from the content providers who push the various content to our centralized cloud. So it depends upon the what kind of that particular scenario, particular place. For example, I'm in Delhi on Connaught Place. Okay, what is the main which are a lot of things going on. Understand sessions are attended. So they push that particular videos to there. Similarly, various applications. So that particular edge got that kind of OTT is pushed there from the central management cluster, and it will be received and it may be streamed. That's I just putting on this. That's the thing.
So I have a question related to that. What is the kind of storage requirement you have on the edge? Are you going to store some content or cache?
Definitely. I think
what is the size of the cache you're looking at?
Sir, actually, it depends upon actually, the traffic at a particular place. See, we created small kind of marketplace where we have
I assume you have had some model for what the traffic would be in a typical location. Let's say 1,000 users are using it simultaneously. Then how much cache do you need? Now, I'm just saying sizing of the MEC, and will this kind of storage be even available in the MEC is something worth at least asking a question. Maybe you're not worth investigating and sizing that out.
Yes, correct. I heard.
Nanda, can I take that? Nanda,
yes.
Can I?
Yeah, Gaurav.
Yes, hi, sir. So, explained by Kushal and Nanda, we have two-tier architecture. One is the central location, and the other is the edge nodes or edge points, which we call. So, the OTT uploads the content at the central location. Not all of the content will be at the central location. Whatever is popular, whatever is required in that location based on the popularity user demand, only that will be pulled at the edge and hosted from the edge, served from the edge.
Okay.
And it's a low, so small footprint which we have at the edge.
Actually, they asking what kind of infra, what kind of edge box you're going to use there. Presently, sir, we're using x86 box for our things. I mean, depends upon traffic, user traffic, other things and all. Presently, we are using x86 server, Dell server. We configured for the some of the gaming kind of things, and some of the high-end videos. But I'll come back with you. Maybe this particular thing is not there with us now. When that data.
My question is a little bit of follow-up of what Praveen asked. I'm saying that this whole intelligence that what content needs to sit onto the edge, right, is owned by you, your application, or is it done by the OTT?
So it's owned by us, but OTT gives us the direction.
Yeah, good, sir.
Generally, what is happening in basically in the normal OTT environment, it is that content is going to the origin and the CDN, basically CDN origin, and the CDN based upon the cache and the thing, it will cache in the POPs of different location of the CDNs. So, are you emulating a POP?
Yes. No, actually, this is quite different. Actually, that's what Saurabh told. Which are the bidding happens. For example, that particular places, what is the main OTT contents are running there. So that is pushed from the central to this. So that is pushed directly to this, and that will be in the as I said, is in cache, and that can be streamed to the customer. Okay. That say, for example, if some content is not used, it doesn't push it. It only where the content is required, it's going to push it and see that it gets streamed from there. But that needs some good computing, at the edge box, at the edge side. So, hope answers are.
There's a low footprint which we have at the edge. So typically, if you see, the storage would be just about a 1 TB. That's it.
Yes. That's one of the this thing on edge. That's what if you are not utilizing that particular content, it will be pulled off from that. Okay, when the content really uses content will go. Answer. So can you repeat?
So I was saying that as Nanda was rightly saying, the content which is not required, it will be flushed out from the edge location, and as per the user demand. So the entire concept is whatever the point of consumption is, you play the popular content at that point of consumption, and fetch it from your central cloud. I mean our central cloud, and serve it at that point of consumption.
Correct.
How? Let's say there is a popular serial which OTT is hosting on their platform, and every day they release a new episode. So the popular or maybe mostly hit episode
will be the recent popular. You say that.
And
what is your algorithm for identifying popular?
So typically it would be the prime time. So that will be defined along with the OTT.
I'm saying there has to be some algorithm. What is that algorithm? You have not described it at all.
No, so
Somebody
that will
manually
be
say these are the popular ones. Let's put that in. Somebody is going to manually do it, or your algorithm is going to pick those.
yeah. So there is an algorithm which, along with the OTTs also, because they have a contribution to that in terms of what are the parameters they want to define, and basis that the content is fetched from the central cloud and delivered from the edge location.
So how many edge location will be delivering this on all because there will be multiple edge locations, correct? Edge nodes. They are local nodes.
Yeah, so sir, it depends where, I mean, what kind of experience people, I mean, user want to get, or what kind of experience is defined by the OTT or the telecom provider, or even independently. We can sit at a tower location, we can sit at a metro location, we can sit at a cluster location, or I mean, just before the GFI. So it depends what is the experience and what is the money which that organization wants to put in.
So that's the point, right? The point is that this whole logic, and intelligence lies with the OTT guys, right? As to who's watching what, in what region, what is being watched, how much of the traffic is there, what they need to cache, what they don't need to cache, what can be, how much they can do, on the fly caching, how much they do, store and forward caching. I mean, there's like significant amount of intelligence that determines how the content gets delivered. So the question that we were really trying to figure out is, have you designed that part of your infrastructure, or what you put together is a MEC infrastructure, right? That's what we wanted to figure out.
Yeah, so it is the MEC infrastructure. Obviously, as you rightly pointed out, that will always be with the OTTs, and specifically because they have a pool of content. But definitely, they do identify which is a popular content. Let's say there is a web series, and there is.
That's not my question at all. I mean, I understand that.
Yeah, so it's the OTT.
The point here is that what you're basically demonstrating is the MEC infrastructure, and then related to that, then my question is that isn't this supposed to be onto the developed, or application needs to be demonstrated on the IIT testbed that IIT has developed?
Yeah, I think we can plan for that, sir. Hello.
Yeah, I know. So you can plan for it. I'm just trying to understand. We wanted to understand what application has been developed, right? Part of this whole demonstration.
Correct.
On the IIT MEC infrastructure, because IIT has put together certain infrastructure with certain APIs, which application provider can use. And that's what we were trying to figure out, if what element of that has been used as well.
No, actually, we didn't use that element. Actually, see, that's what we couldn't do from the MEC testbed. That's what I'm telling. Actually, we not able. We supposed to do it, but we didn't do it because of some reason. Because of reasons, but we as per our where we project in the lab, we just took a recording and we have done a video on showing, sir. If we get opportunity, definitely we'll work on this, I think.
Yeah, the follow-up thing then on that, Nanda, is that the way you have built your infrastructure and you're shown here, I don't think you can do that onto the IIT's testbed.
Yes.
It seemed to
in fact, actually, we shared some of the. In fact, it's correct. You are right question. In fact, before that, we when even the Gaurav has called me and asked me the details, we shared a small list of infrastructure needed. If you provide this infrastructure, definitely we'll try to implement and show to you on the testbed. But unfortunately, we couldn't do that. They say it's quite a huge infrastructure and other things and all. Because see, a lot of intelligence are available, and we coordinate with a lot of other GC our partners. So we couldn't we expected to be showcased with which you provide what we propose. I think we share some Excel sheet. You can go through it. I can forward you, go through it. If you provide that, maybe we can plan for that.
Also, I'm not sure if this even the architecture that is showing us, does it even follow the HC MEC reference architecture?
Yeah, I think it should be. Kunal can answer because that guy is from the team. Yes, I think it.
Yeah, it is. It does follow the
and it is certified as well by VMware. So yeah, it pretty much follows the ETSI standards.
Yeah, then we would have loved to see, what components of that,
Correct. Let us know. Let us know. We are to try to explore this. If it is possible, definitely we'll do it. I mean, we are also not only I think we showing only 1 or 2% of what we build up. We got so many things. As I showed in our technology lab, a lot of things we can know. When 5G, we create a 5G network in our environment. We do a lot
I
of
have
use
to
cases.
cut you in this because I'm running short on time. But my problem is this: that yes, you can, right? You have the lab. You can build any number of any applications. And my problem here was that this was supposed to be onto the IIT's MEC infrastructure. It is not.
Yes, I understand, sir. Yes, I understand. We'll plan for this. Okay. Now I think we can do it. We will plan for this. That I can say now, sir. Okay.
Okay, let's move forward. I'm sorry, I don't have any.
No problem, sir. I know that this thing, but in fact, we told initially about it.
Anyway, I think in the interest of time, let's close it here. And anything else?
Well, we'll go to second use case. Well, quickly end the use case. It is also quite interesting. Contextual ad. I think you team knows about contextual ad. I think Gaurav also gives some input on this. What is contextual ad? But actually, here in this, as I know, it is a business use case. It's running in the It also is a production level. I think we can easily implement in the like any of the places, mall or airport or any places we can import. So this is also a kind of application jointly part of this edge element will do. See, one of the challenges we face that time is lack of knowledge of the visitors. Second thing, time and complexity. Third is lack of new revenue streams. See, people are now every mall, every airport, they look for revenue streams also. Now today, this part, in revenue streams, the many operators building their own infrastructure face difficulties, creating a monetization opportunities. So that's one of the reason and how they can overcome. So that's the reason we this contextual comes to picture, comes into solution what we do. So the outcome will be basically to gain insight to help improve the video efficiency and real-time information on user behavior, location monetization, data impressions, fill rate, and much more. We are formulating. So even when I see, first what Gaurav shared a couple of points, age and gender. Yes, that is there with us. Whenever you capture through a camera, through IP cameras, or through cameras what we installed, it captures. Here we have something more we added. Because phase 2 I'm coming out, but today's demo I couldn't see that phase 2. Phase 2 we're coming with the emotional of the content, and it check out each and every wearables the people are wearing. They're wearing shoes, so they're wearing what color shades, and including the branding also, and in more analytics. And also we can see their person wearing spectacles or something like this. So it gives that respective content. This will be a real time. I think, see, this happens. One of the thing is a real bidding happens here. How a real bidding happens, I'll show you. I'll explain you. So, for example, I'll take an example. I'll go to a mall. I'll install this application in a mall. So, when a lot of crowds are coming, various type of crowds are coming. Some of the group crowds are there. Some of the females come there. Even childs come there. Everything will be there. Okay. Now coming to the focusing on an individual thing, other things and all, where it checks their image, it checks their face, it gives no doubt it gives the age and gender. It also checks out their wearables and gives respect to ads also. And it depends upon even age wise also. For example, if age is 20, 25, then one more ad is there for them. They're the youngsters. They want to add some IC. I mean, some of the instance concept, some of the new this thing is available. If the age is around 45, 50, 60, it has add some of the new class or something. And females, it absolutely females also. It has got a various options for age females. One context will be there. So it's completely contextual and completely emotional, as well as the completely the advertisement will fall based on the appearance also. So the same network, we use the same network. I mean, we run the same use case here. And you can see the performance matter. We see the high data output and increase in network efficiency, 48% in this. And you can see here how it works. So when the people or consumer there, it captures in camera, it goes to the edge box where our platform is available. Then the platform comes to a SSP where the ad exchange are sitting there. For example, they expect 5 to 6. I expected this kind of audience will expect it. So 5 to 6, that particular ad exchange will stream that video or push that content to the edge. So immediately when the particular incident happens, it shows the advertisement. Or morning they say some of the content. So all depends upon it. Even the content provider also have their bidding system. Okay.
Mr. Kumar, sorry to interrupt. We're short of time, so
okay. So that's the thing. And this is the smart part I'm doing. Some of the contextual key connected is say account APIs, campaigning. For example, I want to campaign. If you are campaigning in different places, like some of the huge event happens, then targeting APIs, I can target a particular person, particular things target. I can do that advertisement. Connecting screen, I can have a multiple screen. I can see multiple screen people. I can have a different this thing also. I mean, advertise also, and reporting APIs. I can report to the particular ad guys. Okay, this is all the content that has been contextualized, and this is the more effectiveness. And ensuring API is also there, and real-time bidding, as I said, at particular time, the 10 people want to push the advertisement, so their bidding goes there. So these are a few things are there. I think I'll see. So 2 minutes I can show it. One finished off. It's already One minute, sir. I'm sorry. Sir, please go ahead. Any question? I think it's closed. I think I need to open it.
No, I'm sorry. I think don't need to see the demo, Nanda. I think we're good with this. Thank you.
Okay. So, any questions on contextual ads, sir?
So my question is again, the ad are served from the edge node?
Yes, sir, absolutely, sir. It comes from edge node. That's what from the central team, depend upon ad exchange, connect to ad exchange, depends upon the kind of timing bidding. Ad exchange send the content to the central side. Central side pushes that particular content to the edge, nearest node, that particular edge, because we can see hundreds of edge available there. So that particular edge, what kind of ad content is they're going to push for the central management.
So this content is pushed in real time?
Yes,
the central to the edge?
Yes. For example, if I some activities real time happening, immediately the ad exchange gets this, and particularly will be downloaded in the in the center management downloads the ad to immediately push to the edge network.
Yeah. So will it increase the latency of the edge? Will it increase the latency of actually ad delivered to the screen?
Sir, I didn't get you, sir.
Basically, you are saying that content is pushed in real time from the central server to the edge, and then edge delivers that content to the screen.
Yes.
So this pushing of the content from the central to edge will add the latency.
Yes, 75 milliseconds it pushes.
Yeah. So this is updated in real time at the edge. So content might be pushed from the cloud, but the content, depending on the context, right? The environment, what is the time of the day, how many people are there, what is the crowd detection, all these parameters are captured. For example, we are actually working with a large retail store chain in Australia, right? So they are looking at a lot of retail use cases, and they want to leverage this platform where they want to showcase the perishable items which are getting expired, right? Maybe at 6 or 7 o'clock, right? Some pastries might be there, right? Or maybe some perishable fruits that they want to push it to the customers, right? So they are getting pushed. So they feel that based on the profiling of a customer, that a person is a fit person, right? So they can push some fruit salad or maybe avocado. Some of the perishable items can be shown as the advertisement, and that can be so that can be purchased by the customer. So these are all maintained in real time at the edge location and continuously updated based on these profile, right? Age, gender, sentiment, the body language, emotions, environment, time of the day. And obviously this will change from location to location. It could be a airport, it could be a retail mall, or it could be a shopping center like a Connaught Place or a Khan Market, right? So based on that, advertisements will change. And yeah, there will be a real-time bidding that will be happening.
Yeah, correct.
Okay, thank you.
So one of the best use case we saw in the enterprise is in retail also. That gives more impact for the customers to have their own interest of advertisement. Even when suddenly a child comes, so immediately chocolates comes out. Suddenly, if the fat people if it comes out, immediately all vegetables will come out. So it means you focus more on vegetables. So that kind of contextual type of ads are delivered. That's all. Sometimes it's in closed network available ads. Some of the real-time ads depends upon the what kind of environment we are in. Right, sir. Anything, sir? So any questions? Or I close?
No, thank you.
Okay. Okay. You can close it. Remove the sharing, Pimi.
Okay, thank you.
Thank
you,
you.
team.
Thank you. Thank you all.
Thank you all. Thanks for
Anything
joining.
open, please correct us. Definitely we can definitely be part of it. Thank you, sir.
Thank you, everyone. I now request the jury members to kindly evaluate the applications for the award prizes. We'll take another few minutes while the jury is deciding on these. We have 2 awards for the applications, as I mentioned. One is the most impactful application award, which would be a prize money of rupees 35,000, and the other one is the most innovative award with a cash prize of rupees 25,000. So while waiting for the jury to decide, we shall just walk through the 5G MEC system once again in a little more detail.
Yeah. Thank you.
This is a research demo for development of MEC system for indigenous 5G testbed. And the overview of multi-access edge computing is that it's an evolving technology that integrates the service provider's network with high performance computing facility at the network edge. So the idea is to reduce the overall latency and preserve the bandwidth. We have demonstrated a full-fledged MEC system, including its entities and integration with the 5G core as per the specifications by ETSI for 5G communications with an application deployment use case. The developed MEC system has the capability to integrate with the edge and support various instances of real-world use cases such as video surveillance, augmented reality, IoT-based applications, virtual reality, to name some. These are the applications that may require data offloading or high computing and storage resources. The work is part of the indigenous 5G testbed project funded by DOT, and we have established a proof of concept for real-world deployment of MEC system in 5G environment. The application deployment model in an MEC environment has 3 levels: UE level, edge level, and remote level. UE level could be thought of where the client app stays, such as a smartphone application. At the edge level, MEC host is deployed, which contains an MEC platform and the compute, storage, and network resources for applications running in VM or containers. MEC platform offers a secure environment where MEC applications may consume, advertise, discover, or offer services via the RESTful APIs. So the applications that require real-time computing are supported by the network edge, while the high computing power that do not require any real-time response that can be deployed at the central cloud. The functional design of MEC environment has the following hierarchical order. It comprises of MEC components and information flow. MEC components refer to the MEC entities and interfaces. The schematic diagram of MEC interfaces and entities is shown here. We have UE, UALCM, MECO, MEC host, and the interfaces MX2, MM9, along with other entities. Let's talk about them in detail. So MEC entities, we have a RAN emulator, which hosts the UE endpoints with reference to client app and device app. UALCM enables the device applications to request onboarding, instantiation, termination, and relocation of applications. MEC Orchestrator manages resources of the MEC system. The MEC Platform Manager manages lifecycle of applications. MEC Platform offers virtual infrastructure environment. The MEC Host consists of the platform, which provides compute, storage, and network services. MEC application itself runs as a VM on the MEC edge and interacts with the platform. OSS receives requests via CFS portal for application instantiation or termination. The MEC interfaces have been grouped into 3 reference points that define how the entities communicate with each other. These are MEC System Support Interface or MP interface, Management Reference Points, MM interface, and External Reference Points, MX interface. The MP interface handles MEC platform related functionality such as service registration, discovery, etc. MM interface manages MEC application services, their lifecycle, rules, and requirement. And MX interface are the reference points connected to external entities, UE or UALCM. The MEC entities and interfaces correspond with each other through a standard information flow, which is shown here. It starts with UE that sends a GET request to the UALCM to find the app, and afterwards sending a request to create the context of the service app through GNB and UPF. UALCM forwards all these requests to MECO and sends a response back to the UE. MECO informs the M5G core through NEF and shares UE ID tags such as IP port and other information for traffic subscription. It receives information related to the 5G core, and afterwards MECO performs appropriate host selection. And once the host is selected for the current UE, and the app is instantiated, and the corresponding MECH is informed. At the time of application lifecycle completion, MECO sends a request to MECH for termination of the running app in the platform. And it also keeps a record of all registered MECH and UALCMs. The API level message flow between device app and MEC system starts by device app sending a GET request to the UALCM for finding the app list. The UALCM forwards this request to the MEC system. Upon successful finding of the app list, the response is sent back to the device app. Afterwards, device app sends a post request for app context creation to the system. And here MEC system contacts the 5G core to find location and subscription information for respective UE tag. It then selects an appropriate MECH, and the response, once the context is created, the response is sent back to the device app along with a context ID. In case of sometimes mobility, the device app needs to change some of its parameters. So it sends a put request to the system along with that context ID to update some of its information. Once that is done, the MEC system responds back appropriately to the device app. And at the time of application lifecycle completion, the device app sends a delete request over that context ID to the system. And the MEC system receives this request from the UALCM, and after receiving this request, the application is terminated from the system, and the response of which is sent back to the device app. This part of the session deals with integration with 5G core, and MEC integration is performed with single UPF and 3 UPF options. In case of single UPF option, once the appropriate MEC is selected after the context creation for the application, the packets are directed to the edge MECH or edge server. We can have single UPF where only edge UPF is used and no cloud UPF is used. This may be more of typical of enterprise type of deployment where all the data goes to this single edge location and no partial rerouting is done based on the packet filters. However, this does not improve any latency. While in case of 3 UPF setup, a geographically close to edge UPF is detected. And application function MECO or MECP sends the traffic influence subscription to the NEF in 5G core after selecting the appropriate MECH and creating context for MEC application. And this starts directing the packet to the edge UPF. Thus, the packet is released earlier for routing close to the edge, and it satisfies latency and other MEC requirements. Now, I will demonstrate a use case application on the MEC system. So we have the following setup for achieving the purpose. RAN emulator is where the client app and device app stays. So in this case, we have multiple client applications, one of which is object detection and a tracking application, and the other is face recognition. So in the first application that I'm going to demonstrate, a stream of video that contains two subjects is streamed from the client app to the system, and the MEC app has to process on the input, and whenever a region of interest is detected, it has to relay it to the server. So here I'm running the app. Prior to doing everything, a context has to be created. So a GET request followed by a POST request should be done. It has sent it. The device app has received this request, and now the ULCM will receive it and forward it to the MECO. MECO, upon receiving, selects the appropriate MEC edge, directs the MEC edge to for application onboarding and running the application. Now the MEC edge should have started running the application. Here it is. As we are able to see, the MECH has started processing the input as it receives from the client app. Now, as soon as a person of interest is detected, hereby we have set it as the trigger. The trigger mechanism ensures that whenever a certain condition is met, the input is relayed to a server, to a remote level server. And as soon as the person is detected here, it is relayed on the server. Here it is. The server is successfully able to receive the packets from the MECH. So upon successful completion of the lifecycle application, we are ready to terminate it. Another application that is deployed on the system is a tracking application, wherein on the client side, a camera feed is streamed and that contains pedestrians moving around, and the MEC app on the MEC platform has to process the input such that it has to count the number of bounding boxes it finds, and the trigger there that we have set is the number of people. When the trigger reaches a certain threshold, we are relaying it to the server. So here the application is currently rendering on the server when counter reaches 5 or greater than 5. All right. Now at the time of completion of the application's life cycle, its context is deleted and the app is terminated. This was it. Thank you very much.
So we have the results here. I would request Professor Huzur Saran, Mr. Manish Gange, and Mr. Pratibha Datta to kindly announce the awards. Over to you, Professor and team.
Thank you. So first I would like to thank all the teams. I think they all had very innovative and interesting ideas. I think the Wipro team also had very interesting ideas, and of course IDRBT also. And first I would like to just say that the overall announce for most impactful, I think that's what it's called, most impactful application it goes to the IDRBTP team for their application, which is everybody, all the jury members appreciated, and it seemed very relevant also. So that has been chosen for the award, and I would like to congratulate the team members. Of course, that's all. And there is a small cash award, which Pimi will be getting in touch with the team for. The Wipro, as I said, was also very interesting ideas there. Unfortunately, since one of the expectations and a key component of the requirement here was the actual implementation on the MEC platform, which has not yet happened, and I believe the Wipro team will work with Mr. Shukla on that. So that is why at this stage we felt that that was still a work in progress. So we wish them all the best, and we look forward to seeing the team with a more mature solution in the future. I think that's all I have to say. Brajesh, you want to add something, or anybody else, any of the jury members?
No, sir. Just I just wanted to thank you, sir, and Praveer and Manish for helping us out with the jury part. And of course, the Wipro thing, they've done a good job. It's just that they weren't able to integrate, and we will probably
sometimes things take time. So it's, also as the questions illustrated, especially the video analytics things, it's a pretty complicated thing. Half the knowledge is with the OTT providers. So they may need to, for example, one of the questions that came up, offline we can talk to Wipro, but one of the questions that came up was, say, is it just that we are providing a framework by which OTT operators can do edge? They will decide what gets put there, when it arrives. All of that is done by the OTT guys. Is that the model? Or are they going to try to implement some of those algorithms? Who's going to do it? So there are these are good questions to have. That just shows that it's an important, interesting problem. And MEC is applicable, but there is much more thought needed of how to partition the application between what this solution does and what the OTT providers need to do to offer the final solution. It could be even, see, the larger picture is, see, I am building Airtel Extreme for the mobile phone, and I want to be able to leverage MEC there. So it may need things like this at the back end to be able to achieve it, right? So how that happens is a part of the game. Okay. So I will stop there. We can keep talking about these things, and time is also up.
Yeah, back to you, Pimmi.
Yes.
Okay, thank you, professors. Congratulations, team IDRBT, and congratulations, Wipro, for the great effort. I will get in touch with the team soon. Thanks all the participants, attendees, professors, of course, and all the staff members. A big thanks to TSDSI for helping us organizing this event. Thank you so much. Undoubtedly, this hackathon has helped us in deriving concrete ideas and would be driving a collaborative innovation in the future. Thank you all. Thanks.
Yeah.
Thanks everyone. Great work, Arzad and the teams. And
thanks Pimmi for organizing all of this, and thanks TSDSI for the entire effort. Thank you very much.
Thank you, sir. Thank you for, it was really a pleasure to be on this call and to meet the entire session, IT along with Wipro.
Thank you.
Thank you. Thanks.
Thank you, everyone. Pimmi, shall you close this meeting then?
Yes, thank you.
Thank you, everyone.